I want to welcome you to Advanced Strength of Materials. Today we'll be covering lecture number 0, which is the course overview. So let me introduce myself. I'm Vinay Goyal. I have a bachelor's degree from the Mechanical Engineering Department at the University of Puerto Rico, Mayagüez campus. I have a doctoral degree from the Aerospace and Ocean Engineering, Virginia Tech, in 2002. I have a significant experience in the structural systems as they apply to aerospace structures, experience with composite and metallic designs, bolted and bonded joints, dynamics, failure modes such as fracture, fatigue, and buckling. And I've applied those concepts to both aircraft and launch vehicles. My hobbies are basketball, chess, hiking, beach, and foodie. So contact me if you want to play basketball or play some game of chess or maybe a group hike. That'll be fun. This is a picture of me at the NASA KSC. I've been here at the Cape Canaveral supporting launches this past week. So let's talk about the concepts of stress, strain, and material behavior. That'll be part of what we'll be discussing in this course. We'll be discussing about the stresses in loaded beams with symmetric and asymmetric cross sections. We'll discuss the torsion of cylinders and thin wall structures, shear flow. We'll also talk about stresses in pressure vessels and rotating shafts, curved beams and contact stresses. And also we'll discuss various failure modes that can occur in structural systems such as strength, failure, plasticity, fatigue, and elastic instability. And we'll do our best to cover all these topics. So what is the learning outcome? What do I expect from you to learn from this course? I want you to gain a fundamental understanding of the idea of stress, the idea of strain, the idea of the constitutive law, and how that is used to predict failures of structural systems. This idea of stress, strain, and constitutive law is also used to design to prevent failures from occurring. So what we want to do is to apply those concepts and use that to understand the solution to various problems, such as in beams, thin wall structures, torsion, and pressure vessels. We want to gain a fundamental understanding of the failure criteria in metals, in instability, contact stresses, plasticity, fatigue, and other advanced concepts. What is the course material? We'll be using this book called The Advanced Mechanics of Materials and Applied Elasticity. The shown version here is the 5th edition, but the 6th edition is the one that will be used in this course. The 5th edition is acceptable. PowerPoints and handwritten notes will be provided as needed and will be complementary to the book. I think it's a very good idea to read the book. I will not tell you where to read. I think you know how to use the table of contents, and I think you can go there and say, okay, we're discussing stress. Let me look the chapter on stress in the book. And that's something that a skill that you want to learn because you will experience that in industry. Nobody's going to tell you what chapter to read. You have to learn how to shift through a book. I also have my own book, and my book actually goes into extensive discussions on a lot of the same topics that are covered in this book. So if you didn't want to get this book and you want to get my book, you can also do that. The table of contents can be accessed through this website, and the book is sold through Red Shelf, and you can purchase it there. The grading, the weekly reports, there will be basically 5 homeworks at 30%, no late assignments, 1 midterm at 35%. It will be an in-class exam, closed book, 1 final exam at 35%, in-class exam, closed book. The grading distribution is not grade curving, and the grading distribution is shown at the bottom. So how do I want you to study? I want you to read the book. I want you to attend this practice sessions with the TA on Friday. I want you to attend class, review the lecture notes, complete the homeworks, And I want you to use your thought process and logic as you work through the various engineering problems. I also want you to enjoy the course. You know, when you take a course and you're learning, make it fun for yourself. Have a good time. Take a break. Enjoy it, and have a great time, right? That'll be the preferred way. The course outline is going to start with motivation today. We're going to cover the analysis of stress this week, and then we'll proceed to analysis of strain, stress-strain relationships, strain energy, the plane stress and plane strain idea, which will be covered as part of the stress-strain relationships, the basic relationships in other coordinate systems, stress concentrations, beam theory, and we'll cover beam theory in several lectures, torsion of prismatic bars, we'll cover pressure vessels, thermal stresses, energy methods, and then failure theories. That's what we have planned for you. And we're hoping that we can have a great time doing this together. I want to thank you for listening to this part of the recording, and we'll move on to motivation next.